How to show events are independent. This is the third example. Two ordinary fair dice, one red and one blue, are rolled once. Find the probability of the following events. Event A, that the number showing in the red dice will be 5 or 6. Event B, that the total numbers would be 7 between the two dice. And event C, that the total numbers on the two dice would be 8. We know from the fundamental principle of counting that the total options when you roll two dice is 36, because you have 6 options with the first dice and 6 with the second. 6 sixes are 36. It would be easy to see our options here, however, if we made out a simple sample space, maybe using an array or table to see what our options are. I've done that here. This will help organize our thinking. So event A, the probability that red will be a 5 or a 6. We can see that there's 2 ways of doing this. 2 out of the 6 options, or 1/3 of the answers, will be 5 or 6 when you roll a red dice. Event B is that the totals on the dice would be 7. We might know from the sample space there's 6 ways of doing this. We could have a 6 and 1, 5 and 2, 4 and 3, or vice versa. So 6 out of 36 are 1 and 6. Event C is that the total rolled on the two dice would be 8. The ways we could roll 8 is we could have 6 and 2, we could get 5 and 3, 4 and 4, 3 and 5, or 2 and 6. So we see there's 5 ways of doing that, so 5 out of 36. Then we're being asked to show that the events A and B are independent. If events are independent, they follow the multiplication rule for independence, and that is that the probability of A multiplied by the probability of B is equal to the probability of A and B happening. So this is the rule that we're going to show. So let's work this out. So we want to think about both probabilities together. I've shown them in the picture here. So firstly, the probability of A is 1/3 and the probability of B is 1/6, and 1/3 multiplied by 1/6 will give us 1/18. The probability of A and B happening together, we can see out of the 36 options that 2 of the options are both a 5 or a 6 in the red and total 7. So we see that from the sample space. 2 out of 36, or 1 out of the 18 options, are both A and B. So we can see clearly that the multiplication rule holds in this case. So we could deduce from that that A and B are definitely independent events. In part 3, we're to investigate if A and C are independent. So again, following the multiplication rule, we'll multiply probability of A by the probability of C. So that's 1/3 multiplied by 5/6, and that gives us 5/108. And now we'll work out the probability of A and C happening together. So I'm shading in here the number of ways that you could roll a 5 or a 6, and here the number of ways you can get an 8. We'll see there are 2 ways you get a 5 or 6 in the red and you still get an 8. So 6 red and 2 blue, and 5 red and 3 blue. So that's 2 out of 36, which is 1 out of 18. Now 1 out of 18 is not equal to 5/108. Therefore, the multiplication law does not hold in this case. The probability of A multiplied by the probability of C is not equal to the probability of A and C. So we could say events A and C are not independent.